Recall that a computer executing a program is analogous to a chef following a recipe. A program, like a recipe, is a list of instructions. The computer executes instruction 1, then instruction 2, and so on. Some instructions tell the computer to skip instructions, or go back to a previous instruction, so the execution order is not always linear. A Python program is a list of statements. A Python statement is similar to an instruction, but is more expressive. It also has a very different syntax, as we saw in the previous lessons. Here is an example of a Python program. This program consists of two assignment statements. Python executes y equals 7 first, then x equals y plus 5. The most common way to execute a Python program is to feed the program to the Python interpreter. The Python interpreter comes pre-installed in many computers, but if it isn't, we can download and install it at python.org. Programmers usually start the Python interpreter from a terminal. We encourage you to run or execute the code examples in this course in the interpreter. We can also run Python programs in the Logicwalk Python Simulator, or LWPS. Here is an example. LWPS is an educational tool designed to help students learn Python. LWPS is to Python as LWCS is to the MIPS assembly language. Thus, we can also think of LWPS as a computer. LWPS displays its internal state during program execution so users can see what is happening inside the computer. Also, users can ask LWPS to execute one step and pause, which allows users to inspect the intermediate states of a program as it is running. In contrast, a computer program typically executes as fast as it can, so we only get to see the output of a program after execution is finished. It is difficult to figure out how the results were generated. LWPS is also a Python interpreter, so any code or program that can be executed by LWPS will run just fine in other Python interpreters. But LWPS does not support all Python features, so some programs that run fine in real interpreters will fail to run inside the simulator. Next, let's explore the components of LWPS. The code editor section contains the Python program that will be executed. Currently, there is just one line, y equals 7. We're free to add, change, and remove code. Try clicking on line 1 and typing, or try copying line 1 and pasting it on line 2. The LWPython state section shows the current state of the simulator. The current line indicates which line is going to be executed next. The current tab indicates which tab will be executed next. The line and tab numbers together describe the two-dimensional location of a Python statement. The line is the vertical position, and tab is the horizontal position. We will thoroughly explore tab soon, but it is 0 for now. As with LWCS, time starts at 0. Whenever the simulator takes a step, the time is incremented by 1. As the program executes, more information appears in the LWPython state. We will learn about them throughout this course. There are two ways to execute a Python program. When we click the Next button, LWPS will take one step and pause. In contrast, if we click Run to Completion, LWPS will keep taking steps until the program is finished. Try clicking on both buttons. Notice how the time increases by 1 each time we click Next. This indicates that LWPS is running, moving from one state to the next. After the execution has completed, we can see the variables table consisting of one row. In this row, the left column is y, and the right column is 9. This indicates that LWPS created a new cell called y and stored 9 in it. Try adding x equals y plus 5 to the code editor and see what happens.